So in this video, I'll discuss the coordinate covalent bond. So it is also known as the dative covalent bond. So this is the type of covalent bond where the bonding pair originates from the same atom. So for example, we have ammonia, okay? Meron tayong lone pair na sa nitrogen. Tapos meron tayong H+, this is the proton, okay? Yung hydrogen na wala ng electron. Okay? So, kapag dinonate ng ammonia or yung nitrogen, yung kanyang lone pair dun sa hydrogen, magkakaroon tayo ng coordinate covalent bond. Sa nitrogen lang nanggaling yung dalawang electrons na yan, ng bonding pair na yan. Okay? So, that's a coordinate covalent bond. So, this coordinate covalent bonding is common to coordinate complexes with transition metals. Okay? So, na-utilize ng transition metals yung mga empty 3D, 4s, and 4p orbitals niya or subshells niya to accept electrons from your ligands or to accept coordinate covalent bonds from your ligands. So for example, we have the hexacyanoferrate kasi anim yung kanyang cyanide, okay, na ligands. Tapos yung inyong ion dyan ay Fe2+, so the overall charge is 4-. So we can call the cyanide, an ion, as a strong field ligand. So may dalawa kasi tayong types ng ligands. Strong field ligands, tsaka weak field ligands. So, isa-survey ko lang yung types of bonding dito. Hindi ko na i-discuss yung nature ng strong field and weak field ligands. Ipapakita ko lang sa inyo kung paano ini-exhibit ng valence bond theory yung bonding due to coordinate covalent bonding. Okay? O yung orbital filling due to coordinate covalent bonding. Okay? So, kapag ka strong field yung ligand, ang nangyayari, this is the orbital diagram for Fe2+, makikita nyo empty na yung 4s kasi 4s2 siya kapag ka neutral ion. So wala na siyang electron sa 4s na subshell. So makikita nyo dyan na after the addition of 6 cyanide ligands, nag-pair yung mga electrons ng 3D orbital o yung electrons ng ating Fe2+ para ma-accommodate yung 6 na cyanides. Okay? So the hybridization of the resulting sigma bonds or coordinate covalent bonds will be sp3, okay? Kasi tatlo yung P, isa yung S, so that's sp3d2. Okay? Kaya octahedral yung nagiging geometry ng ating hexacyanoferrate. So, ganyan ini-exhibit ng valence bond theory yung bonding or yung coordinate covalent bonding with a transition metal like iron 2+. Okay? So, kapag naman weak field yung ligand, okay? So, chloride is a weak field ligand. So, meron tayong hexachloroferrate kasi ito ay iron 2+. This is 4- pa din kasi Fe2+, tapos 6 yung ating Cl-. So, meron tayong 4- na net charge for the molecule. Okay? Makikita natin dito na yung ating 3D orbitals or 3D electrons, okay, ay hindi na compress kasi weak field lang si chlorine or si chloride. Okay? So, makikita natin dito na dito nag-add yung ating mga chloride or dyan nag-donate ng electrons yung ating mga chlorides, yung 6 nating chlorides. Okay? So, nagkaroon ng covalent bonding or coordinate covalent bonding sa 4s, 4p, and 4d. So, makikita natin, s, p3, d2 pa din siya. Okay? So, sp3d2 means octahedral yung magiging geometry ng ating FeCl6 4-. Okay? So, some notes. Strong field ligands cause pairing of the inner 3D electrons, while weak field ligands bind without disturbing the inner electrons. So yan lang yung sinasabi ng ating valence bond theory, okay, sa mga coordinate covalent bonds ng mga transition metals. So to be able to expound this, you need some courses on higher chemistry. So pinakita ko lang dito yung valence bond theory on coordinate covalent bonding. So ganyan lang siya na-form. That is the idea on how coordinate covalent bonds form from the valence bond theory. Okay? So, discuss natin yung mga iba't ibang properties ng ating transition metals kasi pag-uusapan natin dito yung mga transition metal complexes. Okay? So, transition metals have high densities due to the large molar mass. Okay? Matataas ang kanilang mga molar masses and mababa yung kanilang atomic radii due to the contraction caused by the poor shielding of the d orbitals. So, maliliit yung sizes nila tapos matataas yung kanilang masses. So kapag nagpo-form sila ng metallic bonds or nagpo-form sila ng mga materials from the same atom, okay, nagkakaroon sila ng mataas na densities. Okay? So recall nyo yung poor shielding of the D and the F orbitals. So matataas ang densities ng ating mga transition metals and ating mga F block elements. Okay? Also, most of them are paramagnetic. So kapag paramagnetic, ibig sabihin meron tayong mga unpaired electrons. So most ng ating mga transition metals ay may partially filled d orbitals. So, meron silang mga unpaired electrons, therefore nag-interact sila with magnetic fields. Okay? So, they also have high melting and boiling points due to the strong metallic bonding exhibited by these transition metals. So, species with varying oxidation states din sila. So, iba-iba yung kanilang mga charges depending dun sa nature ng kanilang environment. Okay? So, pwedeng, for example, yung chromium, pwede siyang maging chromium 3+, pwede rin siyang maging chromium 6+, depende sa environment. So, nag-iiba-iba siya ng oxidation states or may capability sila na mag-possess ng iba't ibang oxidation states. Okay? So, some notes, transition metals are technically different from D-block elements. Okay? So, hindi lahat ng D-block elements ay transition metals because by definition, transition metals have partially filled d orbitals. So, may mga d-block elements tayo na fully filled ang d orbitals. Meron din tayong mga d-block elements na walang d electrons, okay? Kapag nag-exhibit sila ng charges. For example, scandium and zinc groups, okay? So, yung scandium and zinc groups nyo, they are groups 3 and 12. They are technically not transition metals, pero d-block elements sila. So, papakita ko yung orbital diagrams ng ating scandium. So, yung scandium na neutral, pwede natin silang i-consider na transition metal, pero, okay, kapag scandium 3+ na siya, okay, wala na siyang d electrons. Okay? Wala rin siyang 4s electrons kasi 3+ yung kanyang charge. So, hindi natin ito mako-consider na transition metal kasi walang d electrons. So, hindi na lang nila kinonsider si scandium na d-block or na transition metal, pero d-block element si scandium. At saka si scandium kasi, wala siyang iba't ibang oxidation states. 3+ lang yung pinaka-common or pinaka-stable niya na oxidation state kapag cation si scandium. Okay? For the group 12 naman or yung zinc group, fully filled yung kanyang 3d or yung kanyang d orbital or yung d subshell. Kapag naman charged siya, usually 2+ lang yung nagiging kanyang oxidation state. Hindi siya nagkakaroon ng ibang oxidation states like yung ating zinc 2+. So, hindi tayo makakita or hindi common yung ibang oxidation states ng zinc. Zinc 2+ yung pinaka-stable niya oxidation state because of the emptying of the 4s electrons, tapos fully filled yung kanyang 3d electrons. Okay? So, zinc and scandium groups are not transition metals. They are d-block elements, however. Okay? So, kapag transition metal naman, okay, yun yung mga from groups 4 to 11, okay? Kasi 3 and 12 yung ating scandium and zinc groups. So, yung transition metals natin ay nasa 11 or nasa group 4 and 211. Okay? So, kapag neutral, makikita natin, for example, yung chromium, meron siyang 4s1 3d5. Okay? So, half-filled yung kanyang 3d and yung kanyang 4s. So, that's for chromium. Kapag naman chromium 3+, okay, wala siyang 4s, tapos tatlo lang yung electrons niya sa 3D. Okay? Partially filled. So, it's a transition metal. Kapag naman 6+, wala siyang D electrons and S electrons. Pero, the fact that chromium can possess more than one oxidation state, pwede siyang 3+, pwede siyang 6+, we can consider chromium as a transition metal. Okay? So, how do we name transition metal complexes? Okay? So, for example, we have this compound. So, paano natin i-name ang compound na to? So, una natin iti-take note na species inside the brackets are considered as distinct molecules. So, yung nasa loob ng bracket ay isang molecule lang. Tapos, yung ating tatlong chloride ay hindi kasama sa connections ng ating molecule na enclosed by the bracket. So, kapag in-illustrate natin yung kanyang bonding, meron tayong isang molecule. Okay? This is a cobalt surrounded by 6 amines or 6 ammonia ligands. Okay? So, ang kanyang net charge ay 3+. So, tatlo yung kanyang counter ion. Yung tinatawag natin counter ion ay yung ions na yung charge niya ay equal dun sa net charge ng ating cation. So, naka-counter niya yung charge. Okay? Na-neutralize niya yung charge. So, 3 yung ating chloride para ma-neutralize yung 3+ ng ating transition metal complex. Okay? So, since tatlo yung ating chloride, so that's -3, +3, yung dapat yung ating cobalt complex right here. Okay? So, paano ko nalaman na -1 yung chloride? So, lahat ng halides or lahat ng halogens, ang stable charge nila ay laging -1. Okay? Yung group 1 elements naman, yung lithium, sodium, and potassium, lagi silang +1. Yung group 2, yung magnesium, yung calcium, lahat sila laging +2. Okay? So, tandaan nyo yan, kapag alkaline metals, laging +1 yung charge ng kanilang cation. Kapag alkaline earth metals, yung group 2, laging +2. Kapag naman group 17, yung ating fluoride, chloride, bromide, and iodide, laging -1 yung kanilang stable charges. Okay? So, madali nating ma-determine yung charge ng ating complex. Kasi common yung kanilang negative charge, yung charge ng ating mga halides. So, given yung mga charge ng ating mga halides dito. Okay? So, 0 yung net charge kasi neutral yung ating compound. So, ibig sabihin, 3 plus yung ating cobalt complex. Okay? So, since yung ammonia ay neutral molecule, okay, yung kanyang formal charge ay 0, kahit anim pa sila, 0 yung kanyang formal charge. So, ibig sabihin, yung 3 plus ng ating complex ay nanggaling lang sa cobalt 3 plus. So, ibig sabihin, yung oxidation state ng cobalt natin dito ay 3 plus. Okay? So, after determining the oxidation state or the charge of our central transition metal, pwede na tayo mag-name. Okay? So, we have two systems, yung stock tsaka Ewens-Bassett. So, kapag stock system, prefix muna. So, this refers to the number of your ligands around the central atom or yung inyong central transition metal. Okay? Ligands, yung appropriate name ng ligands kapag naka-attach na siya doon sa inyong transition metal in the complex. So, for ammonia, we have the amine, double M. Okay? So, next, yung name ng central metal which is cobalt. Okay? Tapos, oxidation number of the metal in Roman numeral. So, since that's plus 3, that's 3. Okay? So, lagi namang positively charged yung ating mga central metals or yung ating mga transition metals. So, we don't need to mind the charge pagdating sa stock system. Okay? Space, syempre we need the space para ma-name din natin yung ating anion. So, the name of our compound through the stock system is hexa kasi anim yung ating ammonia. Amine is the name of the ligand, ammonia, kapag nakakabit na siya dun sa transition metal. Okay? Cobalt is the name of the central metal. 3 yung kanyang oxidation state. Space, chloride. So, that's hexaamine, cobalt 3, chloride. So, that's the name of the whole compound. Okay? So, hexaamine, so NH3, 6, Cl3. So, that's the name of your compound. Okay? Hexaamine, cobalt 3, chloride. So, kapag ka naman Ewens-Bassett, same lang, prefix, ligand, central metal, pero yung charge ng buong complex yung i-consider natin, hindi yung charge ng metal. So, this charge is expressed in Indo-Arabic. So, 3 plus. Okay? So, included yung charge kasi this is not the charge of the central atom alone. This is the charge of the whole complex. Okay? Again, we have the space and the name of the anion. So, kapag Ewens-Bassett, we have hexa again, amine, the name of the ligand, cobalt, tapos 3 plus yung charge ng buong complex, not just the cobalt. Okay? Space, chloride. So, that's hexaamine, cobalt, 3 plus, chloride. Yun yung name ng ating complex kapag Ewens-Bassett system. Okay? So, some notes on the naming. We have this one, cation first before the anion. So, this is the standard rule. So, yung cation name natin ay nasa left, tapos yung anion name natin ay nasa right, tapos separated sila by a single space. Okay? Then, we have this. If the resulting complex is an anion, the suffix "ate" is used. So, kapag for example, dun sa ating cobalt, kapag cation yung complex, that's cobalt. Kapag naman anion yung complex, that would be a cobaltate. Okay? Maladagdagan ng 8 yung ating central metal name. Okay? So, for example, we have this compound. Name natin siya. So, K3, ibig sabihin 3K+. Okay? Tatlo yung ating K+, dyan. Siya ay group 1 na element. Tapos, we have this complex, Fe. Okay? Cl6. So, this is 3 minus, dapat. Yung Cl natin ay Cl minus. So, 6 Cl minus. So, dapat yung ating Fe ay Fe3+. Okay? Kasi 3 plus minus 6 is negative 3. Okay? So, we can name the compound now. Sa stock system, it's potassium. Hindi siya tripotassium, ha? Hindi tayo naglalagay ng prefix kapag ionic bonding or ionic species. So, potassium, hexa kasi anim yung ating chloride. So, chloro ang name ng chloride natin kapag nakakabit na siya dun sa ating transition metal complex. Ferrate. So, ferrate is the name of iron kapag anion yung ating transition metal complex. So, makikita nyo yung anion names ng ating mga central metals or transition metals sa isang complex from the nomenclature resource. So, nag-upload ako ng nomenclature resource sa Chem18. Okay? So, ferrate, 3 because of the 3 plus of your Fe or your iron. Okay? So, kapag Ewens-Bassett naman, potassium, hexachloroferrate, pero this time it's 3 minus due to the overall charge of your transition metal complex. So, 3 minus yung overall charge ng ating FeCl6. Okay? So, another example, we have this. Copper, na may tatlong ammonia, may tatlong water, tapos 2 plus. So, 2 plus yung overall charge. So, ito yung ilalagay natin sa Ewens Bassett. Okay, okay na yan. Since neutral yung water tsaka yung ammonia, zero yung kanilang formal charges, the 2 plus is just due to the copper. So, ibig sabihin, copper has a 2 oxidation state or plus 2 oxidation state. Okay? So, the name is triamine, triaqua copper. So, mauuna yung amine kasi alphabetically siya mauuna kaysa sa aqua. Tapos yung aqua, that's the name of your water ligands kapag nakakabit na siya sa isang transition metal complex. Okay? So, aqua yung water, amine yung ating ammonia. So, that's triamine, triaqua copper 2. Okay? So, the Ewens Bassett is the same, triamine, triaqua copper, pero 2 plus na siya because 2 plus yung overall charge ng ating transition metal complex. Okay? So, kapag ka naman an ion, we have this one. So, 2 minus yung overall charge. Meron tayong 4 na chlorine, so that's 4 minus. So, ibig sabihin yung copper natin ay copper 2 plus. Kasi, plus 2 minus 4 should be negative 2. Okay? So, since alam na natin yung oxidation state ng ating copper, we can now name the compound. So, 2 for the oxidation state of copper. So, that's diaqua tetrachloro kasi 4 yung chlorine. Okay, malalaman nyo din itong mga prefix na to dun sa ating resource, okay, sa ating nomenclature resource ng ating transition metals or transition metal complexes. Okay, so mauna yung aqua kasi siya ay aqua, okay, yung AQUA, that's mauna siya alphabetically kaysa dun sa chloro. So diaqua tetrachloro kasi 4 yung chlorine, cuprate, okay, that's the anion name of your copper, okay, 2. So, that's the oxidation state of your copper. So, kapag cation, that's copper. Kapag anion, that's cuprate. Okay? So, that's for the stock system of this anion. Diaqua tetrachloro, cuprate, 2 minus naman kapag Ewens Bassett for this compound. Okay? So, another note, it is more advisable to write the ligand with the donor atom on the leftmost side. So, magiging mas useful ang inyong chemical formula kasi magkakaroon na kayo ng information on which atom, okay, yung nagdo-donate ng kanyang lone pair dun sa central metal. Okay, so for example, we have this compound, okay, so that's hexa aqua copper 2 kapag stock system, hexa aqua copper 2 plus naman kapag Ewens Bassett. So, i-rewrite natin yung ligand such that mauuna yung oxygen kasi yung oxygen, yung donor atom. Okay? So, sa water molecule, yung oxygen yung nagdo-donate ng kanyang lone pair dun sa copper 2 plus. Okay? So, here we have more examples. So, for number 1, we have yung tatlong potassium, so that's plus 3. So, ibig sabihin, this is negative 3. Okay? So, ibig sabihin, kung negative 3 yan, at ito ay C2O4 2 minus, so this will be negative 6. Plus 3 dapat si chromium. Okay, so plus 3 minus 6 is negative 3. So, the oxidation state of chromium is plus 3. So, pwede na natin siyang i-name. Okay, so, the name is potassium trisoxalato. So, that's not trioxalato. Bakit? So, the oxalate, okay, so this is the structure of your oxalate. Nakakonect siya sa chromium through the 2 oxygen atoms. So, dalawang coordinate covalent bonds ang dinodonate niya. So, therefore, this is called a bidentate ligand. Okay? So, kung bidentate or tridentate or polydentate yung ligands mo, iba ang naming system natin sa kanila. Iba ang prefix na gagamitin natin. Okay? So, tris, ibig sabihin tatlo. Okay? Kapag ka bis, okay? That's 2. Okay? 2 ligands. Kapag ka tetrakis, 4 ligands. Ginagamit lang to kapag ka polydentate yung ligand mo or it can connect to your central metal through more than one coordinate covalent bond. Tapos, ginagamit din siya kapag ka meron ng prefixes yung inyong ligand. Okay? So, for example, yung ethylene diamine. Okay? So, yung ethylene diamine nyo, meron ng di. Okay? So, hindi nyo na kayo gagamit ng mga mono, bi, tri dito sa ligand na to. So, ganitong naming system na rin yung gagamitin nyo. Okay? So, ginagamit yan kapag ka, again, polydentate yung ligand, tapos kapag ka yung inyong ligand ay meron ng prefixes or meron ng positioning prefixes. Okay? So, proceed na tayo sa naming. So, trisoxalato, chromate, kasi that is an anion. Okay? So, an ion name yung gagamitin natin. So, 3 because of the oxidation state of your chromium. That is for the stock system. Kapag ka Ewens Bassett, potassium, trisoxalato, chromate, 3 minus because of the charge of your anion. Okay? So, for the next example, we have this compound. So, dalawa yung magnesium. So, ang isang magnesium ay plus 2. So, this is plus 4. Okay? So, ibig sabihin, this is 4 minus. So, the Cn here is Cn minus 1. Okay? Or just Cn minus. So, ibig sabihin, this is negative 6. So therefore, this is plus 2. Kasi plus 2 minus 6 is 4 minus. Okay? So the oxidation state of our iron is plus 2. So for the stock system, we have magnesium, hexacyano kasi 6 yung ating Cn minus ligands or yung cyanide ligands, ferrate because of the anionic character of our transition metal complex. So gagamitin natin ay ferrate, hindi iron. Okay? So yung 2, that's the oxidation state of your iron 2+. Okay? So for the Ewens Bassett, magnesium hexacyanoferrate, pero this time 4 minus because the charge of our transition metal complex is 4 minus. Okay? So for the next example, we have this compound. Okay, makikita natin na may dalawang bromide. So Br minus to. So this is negative 2, therefore this is plus 2. Since neutral yung ating water at ammonia, copper should be the plus 2. Okay? So alam na natin yung oxidation state ng copper. Again, we can rewrite the H2O in terms of which is the donor atom. So pwede natin siyang isulat as OH2, 2. Okay? Pero makikita nyo rin kasi sa ibang literature na H2O lang yung nilalagay nila. So, you can do either way. Pero mas informative kapag ka OH2 yung ilalagay nyo. So, nilalagay ko lang na H2O para madaling ma-determine yung klase ng ligand. Okay? So, sinasanay ko lang kayo dun sa OH2 habang obviously pinapakita ko na water siya because that's an H2O compound na nag-act as ligand dun sa ating transition metal. Okay? Para mas madali siyang ma-identify this time. Okay? So, this is the compound. Plus 2 yung overall charge ng ating transition metal complex. So, cation siya. We will use the copper, okay, instead of the cuprate. So, the name is tetramine. Mauuna yung amine sa aqua alphabetically. So, diaqua. Dalawa yung ating water. And copper 2 because of the oxidation state of copper. Space bromide. So, because of the Br2. Okay? So, for the Ewens Bassett, tetramine, diaqua, copper 2+ because 2+ yung charge ng ating transition metal complex. Space bromide pa din. Okay? So for number 4, we have this compound. Okay? Tatlo yung ating bromide, so this is negative 3. Therefore, the complex is plus 3. Since neutral yung ating water, again, you can write this as OH2, 6. Okay? So neutral siya, therefore, the plus 3 is for the chromium. So the oxidation state of chromium is plus 3. So the name of the compound is hexaaqua, 6 na water ligands, chromium 3 for the oxidation state of chromium, space bromide. So for the Ewens Bassett, we have the hexaaqua chromium plus 3 kasi plus 3 yung charge ng ating ligand or yung ating complex, space bromide. Okay? So for the last example, we have a complex cation and a complex anion. So nag-form sila ng salt. Okay? So how do we determine the charge of the complexes? So since 1:1 sila, okay? So isang complex na cation at isang complex na anion, we will assume that the charge of the cation is A. Tapos negative A yung anion. Okay? So since equal sila ng charge magnitude, we can write this. Alam natin na yung ONO, okay, ay negative 1. So A plus negative 6 should be negative A. So therefore, negative 2A is negative 6. Therefore, A is plus 3. So ibig sabihin, the charge, okay, is negative 3 for the anion plus 3 for the cation. So ibig sabihin, kung negative 3 to at negative 6 due to the 6 ONO or the nitrito ligand, so this should be plus 3. Okay? Since plus 3 to at neutral yung ating ammonia and water, this is plus 3 din. Okay? So now we can name the compound. So the name is tetramine. Una again yung ating ammonia. Diaqua cobalt 3 because of the oxidation state of the cobalt. Space hexanitrito cobaltate 3. So cobaltate na siya dahil siya ay anion na dito sa complex na ito. Okay? So sa Ewens Bassett we have tetramine, diaqua cobalt 3 plus kasi plus 3 yung cation na to. Space hexanitrito cobaltate 3 minus kasi 3 minus yung charge ng ating anion. Okay? So this is my discussion on naming, writing, and determining the properties of your transition metal complexes. Okay? So magpo-proceed na tayo sa introduction to organic compounds and intermolecular forces of attraction sa susunod na video. So see you next video.